Excessive cranking and hard to start fault on this Toyota. It's a VVTi engine and the customer complaint is intermittent hard start, but under the same conditions every time, which is when it's left overnight or for a long duration of time, the vehicle is very difficult to start and the customer is getting worried. In this video, I'm going to show you the steps I use to diagnose and fix that fault. And before I jump into the hard starting fault on that Toyota and go through the process on how I confirmed the fault or just show you some of the testing on confirmation of it, I wanted to showcase the kit I actually use in a lot of my diagnosing. So a hard starting fault on that Toyota when the vehicle is left for a certain duration of time, my diagnostic pathway in that case is to always look at the fuel first and start to work from there. Reason being, if the fuel pressure is dropping off over a number of hours, we're going to have a hard starting fault. So we can suspect the likes of the injectors, the check valve, fuel pressure regulator, etc. And this kit is going to be able to isolate that down for me. And why I wanted to talk about this kit is I have come across these similar problems a lot over the years, and in one case a Nissan had been to other workshops and they couldn't pinpoint exactly down the fault and they didn't want to confirm what he needed to do to rectify it. And I think it boils down in a lot of cases to the accessibility to this type of equipment. This is a multi-purpose pressure gauge kit. It's got a load of different accessories. We have manual there, but you've got loads of ways to tap in. That's got a valve inbuilt, got a T-piece over here. That's one of the ones I commonly use, and we've got different pipes and clamps, etc. to use it in. This would have been a very expensive kit, especially in the earlier years of my career, but through mass manufacturing and a lot of different countries producing these now, we can buy these online for extremely cheap in comparison to what they were. I think that workshops over the years have become, let's say, disconnected from technicians in what they want to put into the workshop versus what they want the technicians to provide. And I think that's a real battle that will be ongoing forever in regards to that. What should techs have in regards to equipment versus what the workshop should provide? This one sits in between that, and in those garages that those vehicles came to me after for confirmation testing, I believe that was the problem. I think the techs didn't have the equipment. They very likely knew what to do, should they have, but the garage didn't provide it for them either. And then you're stuck in this limbo of guessing, which is where you definitely do not want to be as a tech. Having a kit like this makes it very simple to be able to diagnose these problems when you think about them. So I wanted to share a couple of tips that I have used to diagnose those type of problems. The first one is, obviously, we have the gauge. We're checking the operating pressure, and that's the running pressure when the engine is running. So then we can confirm that the fuel pump is able to get it up to enough of an operating pressure. We can also kind of rule out that we don't have any kinks in the lines, like there's no issues with lines breaking down, fuel filter being blocked, issues with dirt contaminants in the strainer or something, because the operating pressure is willing to get up to that and stay at that operating pressure. If we turn the vehicle off, back on again, number of times we can keep getting that. So again. And again. Okay. Then we can do a road test where we monitor the operating pressure, and we're confirming that everything is good on that. A hard starting fault left over a number of hours is a different approach to it, because we're looking at if there's fuel pressure lost, and that's where I always start my testing on a case like this. I always go to the fuel pressure and check to see if we have a drop off. So the residual fuel pressure drop off, again, it's different for a lot of manufacturers. Here is a manual of what operating pressures should be in a load of different engines, but they vary, is what you want to know. They vary from 15 to 50 psi across the board. There's loads of different ones. The residual drop off is going to be different as well from manufacturer to manufacturer. In this Toyota I'm working on, I believe it's somewhere around 21 psi. After 5 to 10 minutes, it shouldn't drop below that. In reality, the pressure, they stay way higher. So from 40 to 50 psi is the kind of operating range. When the engine's turned off, it should stay high. I'm not looking to see it drop off fast. And then overnight, we certainly don't want to have the pressure where it's dropped down low and in some cases zero. Therefore, we have confirmed that the pressure is losing and it has to be built up again. Now, how we can do some tests on that. We want to confirm fuel pressure regulator or check valve, something like that is causing it. And how we can do it, or leaking injectors, is divide the system. So let's say this is a pipe, we have our gauge hooked up, we can clamp off. So let's say this is the inlet pipe from the tank, we have the pressure hooked up directly to the rail. After we have it all ran up, we switch off the engine, we can then clamp and see. We've already confirmed that we have a certain pressure drop off, let's say within 20 minutes, 30 minutes, and we want to confirm if that stays the same when this is clamped off. If it does, if the pressure is still dropping off, the issue doesn't lie back here, because now we've blocked this line, so we can look straight to see if we have rail issue in regards to leaks around there, fuel injectors dropping off. And if we do, we can then pull the spark plugs, look to see if there's wetness there, maybe put a borescope down into the cylinder, check to see if there's wetness on top of the piston, and we have confirmed where the fault is. Those tests seem simple by saying it. It is. The hardest part is picking the correct adapter and connecting up, but in some cases they can be extremely easy. These kits make it easy because we have quick fit adapters in line and we can connect up easier than we ever would have previously. I use this T-piece a lot as well, and it makes it very simple and effective to get the results. Again, confirm off your technical information on your particular engine. That will give you the exact readings you should expect. But if you have a pressure that's dropping off, bleeding off fast, you have an issue, and then you can isolate it down by doing those simple tests. Back to the Toyota that I'm working on now, I'm going to showcase the drop off in pressure that this one was getting and where I then focused on. So back on the Toyota, I'm showcasing here the connectors and adapters I picked out of that kit to hook up the fuel pressure gauge on this Toyota. I worked on another vehicle after hooking this up, and then I came back to it to check what the pressure was after a certain duration. And we have less than 10 psi, which is a confirmed fault, and I know there is a bleed off here that needs to be rectified. I run the engine then because I want to see the operating pressure after that fall off, and it's got above 30 psi in pressure and it's gradually going up, but I'm not happy with that operating pressure either. It should be a bit higher than that. I've confirmed there's a fault. Off camera, I did confirm that it was downstream towards the tank, so the next thing I'm doing is getting to that in-tank assembly. Someone's obviously been in here before. The cap for the tank fuel pump assembly is all taped up. And what I'm looking to get at here is the in-tank fuel pump, which has the fuel pressure regulator inbuilt in it. I did talk to the customer. They gave the go-ahead to replace this complete item. It comes as one unit and it's not difficult to get. It was actually on the shelf at the part supplier. This is me just demonstrating the actual tool I'm using to take that ring off to get at the in-tank fuel pump. They can be very tight. You can use a hammer and a screwdriver to get it off. This is a Ryko kit that I find very useful for not doing any damage on that ring when removing that item. So I've now installed the new part, and here is the reading with the engine off, nearly 40 psi. I take a look at the time because I'm going to do around 20 minutes approximately and recheck to see what the pressure drop off is. Engine is running perfectly. The operating psi was above 40 as well, so I am very happy with that. It's coming up on 11:30, and then I can see that it is around 38, 39 psi on the gauge. I didn't have to disconnect anything, I just left it, and we can see it's nearly 10 to 12, so approximately 20 minutes, no real drop off at all in pressure, and this is now rectified. Another happy customer after this was fixed. No more concerning cold starts where the engine is cranking a very long time and they're wondering if they're going to be able to get to their destination or not. By using these simple steps, a kit like this, you too can do easy diagnosing on fuel related problems like on that VVTi or on the Holden I shown earlier. Monitoring the gauge, looking at the operating pressure, looking at that residual drop off are all key indicators on where a fault may lie. I really hope you enjoyed this video. I hope you found it useful and informative. If you did, please like, share, comment and subscribe, and I hope to see you in the next one. Thanks for watching.